Hello everyone, in this video I'm going to teach you how to do tutorial for circular motion. We have 5 cases altogether, but in this video I'm just going to focus on case number 1, which is turn on flat surface, and case 2, which is conical pendulum. Now let's get to it. You can pause this video to read this question. I'm going to straight away go to the solution. Now let's do the listing. We have mass of the car, which is 1200 kilograms, and then we also have the radius of the curve, horizontal curve, which is 50 meter. The coefficient of static friction is 0.4, and we have to find the ES maximum speed of the car without skidding. So we straight away going to use the equation of V equals to square root mu RG, okay, and then we're going to substitute all the information, which is 0.4 times R is 50 meters times 9.81, and the answer is 14 meter per second. Question B is asking for the car begins to skid at the speed reaches 10 meter per second. Calculate the static friction mu s. In this case, we're still going to use the same equation, but this time we're going to add we're going to do the substitution on different area. The velocity, the mu is the one that we're looking for. We're going to use the same radius, which is 50 meters, and also the same gravity. So the answer for the mu is 0.204. Alright, let's go to question number 2. Again, you can pause the video to read the question. So let me do the sketching first for this question. So I have a disc, and then I have a block here, and then this block is tied to a string, and the radius is 0.8 meter as the disc rotates. We also have the angular velocity, which is 6 radian per second. What else we have? We have the mass, which is 0.6 kilograms. Yeah, that's it. So question number 1A, if the spin is with the angular speed here, calculate the speed of the block. Okay, so we're just gonna change the angular frequency of this rotational motion into radian per second. Sorry, not into radian per second. We have to change it to tangential velocity. All right, so question number 1A is V equals to R omega. The R is 0.8. Now this one is radian per second, so we don't have any problem because this is the basic unit for angular frequency. Hence we just straight away substitute the 6, and then once we calculate it, and we got 4.8 meter per second. For question number 2, we have to find the tension of the string, and because this is not the typical, making a circular motion on a flat surface where you are depending on the friction, this time we are depending on the tension. And for that, we need to draw the free body diagram for this object, for this block. We have weight, we have normal, and obviously we have tension, and the centripetal acceleration is also towards the same direction as the tension. And we're going to use summation of force, Fc equals to mv squared over r. The tension is the one that we're looking for. Mass of the block is 0.6, then velocity is 4.8 squared over r is 0.8. So the answer for the tension is 17.28 Newton. Next question, the string can withstand a maximum tension of 20 Newton before snapping. What is the maximum speed the block can have without breaking the string? Just now we have T equals to mv squared over r. We're going to add in the 20 Newton into the equation. The mass is the same, which is 0.6. The velocity that we're looking for, and then the radius is also the same. So we just do the sum calculation. So the velocity is 5.16 meter per second. Now let's go to question number 3. This one is for the conical pendulum. Again, you can pause the video to read the question. I'm going to do some sketching for this pendulum, and what I see here, I have the tension which is 30 degrees to the vertical, so this is it, which is equivalent to this one. Okay, this is also 30 degrees, and because I'm doing the free body diagram, the angle must coming from the object itself, so I put it here. So we have to find the tension in the string. So this is quite easy for us to do. We can find the tension because we have the value of, because we have the mass, so we can find the weight, and that is equivalent to the T cos theta. So we're going to use summation of force at component y equals to 0. And then we have here T cos 30 degrees minus mg equals to 0. And then, you know what, I'm just going to put here W, and then when I change the W to here, it's going to become positive, and I'm going to substitute it with mg because we know that W equals to mg, right? So T equals to mg. You know what, I'm going to straight away add in the value 9.81 divided by cos 30 degrees, and we do some calculation. So the answer is 5.66 Newton. So that is for question A, and now we want to do question B, where we have to find the speed of the pendulum. For the case of pendulum bob, you can either use the equation for the velocity where you can use rg tangent theta, or if they don't give you the r of the conical of the circular motion, you can also use LG sine theta tangent theta, and this is what I'm going to use. The L is 1.2, G is 9.81, sine 30 degrees, and tangent 30 degrees. So the velocity is 1.84 meter per second. But what if I don't want to use this equation? I can also use the V equal to third rg tangent theta, but I have to find the r outside the equation, and it looks like that. You can see that this is the triangle where the angle is 30 degrees, so I'm putting it here. We want to find this one because the circular motion is on the horizontal side, so we have to find the r, and for that we're going to use sine. So r equals to 1.2 sine 30 degrees, which is basically the same thing. So this one we got 0.6. When we add into this equation, 0.6 times 9.81 tangent 30 degrees, you're still gonna get 1.84 meter per second. It's the same thing. And the last one, question number 4, again, this is also using the conical pendulum as an example. You can pause this video to read this question. So I got my kite, and the string is 2 meters, and then it also mentioned about the radius is 0.8 meters, and the kite takes 2.5 seconds to complete 1 revolution, and that would be our omega. 1 revolution to 1.5 seconds, so I need to change it into radian per second, and for that I'm going to times 2 pi, and that is 2.541 radian per second. To get the angle, I'm just going to use Pythagoras theorem. This is 2 meters and this is 0.8 meters, hence I can use the sine to get the angle. Sine theta equals to 0.8 divided by 2 meters, so the theta is 23.6 degrees. And to get the tension, I'm going to use the same equation that we've used before, and you can get the answer is 5.35 Newton.